And I'll start with the second major, which contain chapter 10 and 5. I will start with chapter 10 and 5, and then we'll go to first major in 191, in which we have the first 4 chapters. Which of the following statement is false? T absolute temperature, N mole, and V volume, and P pressure. At constant pressure and number of moles, and changing the T from 100 to 200 causes the volume to double. Is this true or not true? Yes?
True.
No, wrong.
No.
False. It should be Kelvin.
Yes, if it's 100 Kelvin to 200 Kelvin, then it will double. But with this one, what will happen is, this is the volume 1 over 100 plus 273.15 equal to V2 divided by 200 plus 273.15. And this way it will not double. So this is the wrong statement. Good. Okay, 0.345 gram sample occupy 120 milliliter at 100 degrees C and 1 atmosphere. What can you calculate right away?
The molar mass.
Number of moles.
N, number of moles, not molar mass. N, how can you calculate the number of moles?
P times V divided by RT.
Which is, what should I write? 0.120 liter times 1 divided by 100 plus 273.15 times, what's R?
0.02.
Okay, give me the final answer.
Would be 3.9 times 10 to the power minus 3.
What's the molar mass?
M divided by N.
What's the answer?
88.
88.
What again?
88.
88.
Yes.
Okay. Now you know the mass is 88 mu or gram per mole or whatever. Which one of these compounds have this mass? You have to do each one by itself.
The first one, A.
First one, it must be the first one. It's always the first one for this exam. But yes, that's what you should do. Once you calculate the mass, then you should go back to these and find which one matches this mass. Good. A certain hydrate has the formula MgSO2.XH2O. A quantity of 54.2 grams of the compound is heated in an oven to remove all the water molecule. If the steam H2O gas generated exerted a pressure of 24.8 atmosphere in a 2-liter container at 120 degrees C, determine what's X. Again, what are you going to calculate? The first thing.
Number of moles.
Number of moles. Number of moles, M, which is equal to what?
PV over RT.
PV over RT. We have the atmosphere 24.8 atmosphere times 2 liter. 2 liter divided by 120 degrees C plus 273.25. This is of course times 0.0821. Give me a final answer.
1.536.
1.
0.5
Yes.
6. Yes.
That's it. No 10 to the power
1.536.
only. Okay, good. This is the total number of moles of water. All right. We want to know what's X. How can you tell?
Find the mass.
Find mg. First, what's the mass of mg? Is 04.
You mean molar mass?
Yes.
$120.38.
This is for mg is 04. mg is 04. It is 120.38 plus X mole of H2O. Okay, give us X times, sorry, not X mole, H2O. X X times 18.02. Right. This gives us the total mass. Okay, number of moles of Mg SO4. What's that equal to? Dot XH2O. You divide this number, which is 54.2, divided by 120.38 plus X times 18.02, which is the mass of the water, and this will give you the number of moles. This will give you X mole. This will give you the number of moles. If you calculate this mole, this will give you X mole H2O. Because why? Why? Because in the equation, Mg, this one, what is it going to give us? Mg SO4 plus X H2O. So if I have this number of mole, which I calculated here, this is equal to X mole of H2O. And this one, we calculate to be 1.536. So what is the value of X from this equation? Calculate the number of X. No. $54.2 divided by 1.536. equal to 120. I don't have a calculator and I'm not doing any work, so plus 18.02 x. Calculate what's x. That's it.
It's give me, doctor, a negative number, negative 4.7.
Yes, the same.
Okay. This team.
نقسم العدد دكتور على 18.02 صح؟
minus 4 بس كده.
إيه. أنا آسف أنا آسف. إكس لحظة شوي إكس. اسمها هذا المول نمبر اوف مول. This 54.2 divided by 120.38 plus x times 18.03. Get a number of mole.
Doctor,
Now,
couldn't we find first the mass of water, then subtract it from the mass to get MgSO4?
yeah, no, that's much better. Yes, of course. I agree with that. Oh, fantastic. Then change this to mass. Yes, I agree with this. Oh, I like this suggestion. Calculate this in gram.
27.67.
What again?
27.67.
27.67 gram H2O. Then how many grams in GSO2? SO4. In GSO4, how many grams? Only without the water, which is 54.2 minus 27.67. I like that, yes.
$26.5
26.5.
grams.
Good. 26.5. Calculate the number of moles.
دكتور MgSO4 is 120.38.
120. The mass, you mean?
Yes.
Yeah, of course. I'm not doing any work. Find what's the mass of MgSO4 from the periodic table. Divide this number by the molar mass.
0.22.
Is the number of moles?
Yes.
2, sure.
Yes.
Who got the same answer?
I think it's correct. So we can
Yes.
divide 1.5
Exactly.
by
To
0.22.
1.536 divided by 0.22.
That will get
6.98, which is approximately 7.
So yes, this is the correct number, is 7. Good. All right, good. Let's move quickly. Okay. In an experiment setup as shown below, where 2 liter of a bulb has a pressure of 1.9 atmosphere and is connected to 3 liter bulb where the pressure is 3.20. 1.9 atmosphere. Okay. After the bulb is separating the 2 bulbs is opened, what will be the final pressure in both of them? What can you do?
write 2 equations.
Now, what kind of equation? What equation you're going to do?
BV equals PV.
V1 equal V2.
Yes. Okay, so P1 over V1 equal to P2, no?
P1 multiplied by V1.
Times.
Actually, we have to find number of moles. The best thing is to do the number of moles, which is P1 V1 على N1 equal to P2 V2 على N2. Because the temperature is the constant. And so, yes, we have to calculate the number of moles. Just a second.
I think we don't need the N here.
Yeah, you agree. P2, P1 over V1 equal to P2 over V2. Yeah. Okay. Yes, we do need this. We'll do it first. We'll do each one by itself. I'll call this one the for the first pressure. The first one, it was 3.2 the pressure and the volume was 3. If I change, assume that this is not available at this time. If I change the volume from 3 to 5, what will be the pressure of this bulb only? So I'll do 3.20 divided by 3.0 equal to P2, which is the pressure. I'll call it P2, fine. So I'll call this one P1 and this P2. P2 over V2, which is 5 liter. Okay, then I'll do the same thing with the second one. I'll do 1.90 divided by 2.00 equal to P4, I'll call it, because I consider this as P3, P over 5 liter. Find what's P2 and P4, then according to total law, P total will be P2 plus P4. Because as if the other one is not available. What's P2? Can you tell me what's P2?
Doctor, the law says
Doctor,
I think it's wrong.
V1.
What's P2 first?
Doctor, I think the equation is wrong. Isn't it supposed to be V1 equals V2 V2?
Sure. I'm doing so many mistakes. All of this is, of course, all nonsense, of course. P1, that's for temperature. So yes. Okay, now let me do everything from the beginning. I will say this one, I will set it to be, this is V1, and this is P1. And this is V3, and this is P3. Okay, now P1, V1 equal to P3, V2, V2, okay, which is, I assume now that P3 is, I mean, the pressure from the other valve is not available at all. I consider that I opened the valve and the gas, the same gas, this gas only went to the other side. So what's P2? P1 in this case is V1 is 3 and this one is 5, and of course this one, the pressure is 3.2. So what will be P2?
1.92.
1.92. Then I'll do the same thing for this one. I'll say P3 V3 equal to P4, which is, I assume again that this gas is not available, and this gas is going at all the sides, times V4. Now again, this one is 1.9, the pressure, and the volume is 2, and the pressure 4, I don't know, and V4 is 5. So what's P4?
0.76.
Now, the total pressure, according to Dalton law, is the summation of P2 plus P4, which is equal to what?
2.68.
2.6.
8. Yeah.
Got it?
Yes.
Very good. I don't know what's wrong with the computer. All right. Now let me know this. Where's the... Okay, good. Can you see now?
Yes.
Yes, yes. Okay. At 200 K, the molecular atoms of an unknown gas have an average velocity equal to that of argon at 400 degree K. What is X? Assume ideal behavior. What's X? What should we do?
Use root 3RT over.
Make
Yeah.
equal.
So, velocity of unknown divided by velocity of what? Argon equal to what?
The square root of the molar mass of argon over the X.
Molar mass of argon divided by molar mass of unknown X. So what's the molar mass? We know this one, we know this one. What's the molar mass of X? Sorry, yeah, molar mass, not T.
Doctor, what about the variation in temperature?
At the same temperature, if there is a temperature change, we cannot do it.
There is a temperature change.
Yes. 200 Kelvin and 400 Kelvin.
No, this is comparing. That's the rate. Yeah. Yeah, this is velocity. Okay, right. Oh, again, making mistakes. Okay. Just a second. Just move that. Okay. No, I'm making a mistake. I cannot compare like this. So again, all right. Now, what should we do? We know that half mu squared, okay, times the Avogadro's number equal to 3 over 2 RT. So
Doctor,
yes,
we can use root CRT over molar mass in kilograms.
Yes, shouldn't we make them equal? Square root of 3 RT divided by molar mass is equal to the same.
okay, let's go with that. 3 RT over molar mass. Let's do this, yes. What's the speed of argon?
Yes.
Of course, which R we're going to use?
It will be
8.300.
will be 500.
500
Yes.
meter per second. Okay. Since the gas unknown has the same speed, this means 500 meter per second is equal to what? 3 RT divided by molar mass. So what's the molar mass?
Uh, 19.95.
Yes.
19.95. Very good.
Approximately 20.
Which gas is this one?
HF.
Why? Because the fluorine is 18 and hydrogen is 1. Okay.
Doctor, isn't the fluorine 19 and the hydrogen is 1?
Yeah, that's I said 18, I said 19. Yeah.
But when I add them will be equal to 20 approximately.
About 20.
Doctor?
Okay.
Yes.
Doctor? Yeah, can't I just equate 3 RT over molar mass equal 3 RT over molar mass?
Yes. Oh, that's exactly what we should do. We should have done. Because that's what we did. We calculated and then we calculate this one. We don't have to calculate it. We can just do it right away. We can say 3 RT over molar mass of X, square root of course, is equal to 3 RT over molar mass of argon. And this way it will be much easier for us to say 3 RT over molar mass of X is equal to 3 RT over molar mass of argon. This way the 3R and 3R will go away and then we can have the answer is 200 over molar mass of X equal to 400 over molar mass of argon, which is, what's the molar mass of argon? Should be about 40.
39.95 per gram.
39.95. And so what's next in this case? So about, which is the correct answer. So that's an easier way to do it. Good. Let's go to problem number 6. Calculate the standard enthalpy of reaction for this reaction to get this result. What should you do with the first equation?
Flip it.
Flip it. CS2 goes to 2S plus C, and delta H will be minus 115.3. How about the second equation?
Nothing.
Nothing. Exactly. C plus 2Cl2 to give you CCl4, and the heat will be minus 128.2. Okay, and the next equation also. Also nothing.
Nothing.
To do what? S2Cl2, and so this will be minus 58.2. The 2S will go with the 2S. The CCl4 is a result. Okay, good. And the carbon will go with the carbon. And the rest will be CS2 plus 3Cl2 to give you CCl4 plus S2Cl2, which is exactly like the up there, and you add these three numbers. How easy?
Easy.
Good. Next, ethanol undergoes combustion in oxygen to produce carbon dioxide and liquid water. Okay, so ethanol, which is in this case, ethanol is C2H5OH. React with O2. Of course, any organic compound, when it reacts with O2, what is going to happen?
CO2 plus H2O.
CO2 plus H2O. What's the next step that you must know?
Balance the equation.
Balance.
Balance the equation. So this is 2, and this is 3. And that's it, it's balanced now. Of course, oxygen, I don't care about it. All right? If you notice that we have 2CO2 plus 3H2O. And this one, I don't care about to balance it. Why?
Because the delta HF for it is 0.
Yes. And when I calculate the heat formation, it will not calculate. Okay. What is the standard information of ethanol? So the heat of this reaction is equal to minus 285.8. Then this is equal to what now? Two times heat of formation of CO2 plus what? 3 times heat of formation of H2O minus heat of formation of C2H5OH.
Doctor,
I have this one, I have this one, I have this one. There's the only thing I don't have. Calculate it. Yes.
Doctor, isn't the 200 outside would be 1,366?
Yes.
Because it's the heat of the combustion.
Sorry. Of course. I'm trying to go fast, and when I try to go fast, it seems like I'm not concentrating. So yes, this is 1,366.8 into the minus C. Okay, so we know this one, which is the minus 285.8, and this one is minus 393.5. So calculate x, or plus x.
I'm with 6.
What?
Minus 277.6.
Which is the correct answer. I hope you got it. Okay, number 8. When 0.7521 gram of benzoic acid was burned in a calorimeter containing 1,000 gram of water, the temperature rise to 3.60. What's the heat capacity of the bomb calorimeter, excluding the water? The heat combustion of benzoic acid is minus 26.42 kilojoule per gram. So what's Q in this case? Q reaction.
Multiply by 0.7521.
Exactly. 5 to 1. And what's the answer?
Minus 19.87.
19.87. That's the heat for the reaction. What will be the heat of calorimeter plus water and plus Q of calorie of water? What will be the heat?
Would be positive 19.
Which is 19.87 without the minus. Okay, what's the Q of water? We know it. It's 1,000 gram times what?
4.1
4
times 3.6.
3.60. And this is, of course, times 10 to the power 3 to make it joule. All right? What's the Q calorie? C of calorie times what? 3.6. That's it. And this is equal to 19.87 times 10 to the power 3. What's C?
1,335.4.
1,354?
35.
Oh, 35. 1,1335.
Yes.
Yeah. Joule, in this case, which is actually equal to 1.34 kilojoule. Good. Okay, chemical energy. Chemical energy is the energy stored within a structure unit of chemical substance. What's a chemical energy? It's related to what?
Potential energy structure unit.
Position.
Bonds. And that's why it is related to structure of unit of chemical substance. It's related to the chemical bond. And that's why this is the correct one. The energy associated with random motion, is it related to the random motion?
No.
No. Is the energy related to come from the sun?
No.
Of course, it's not chemical energy. Okay, we have light energy or wave energy. Is it the energy available by virtue of object position, where the position is? No. Okay, is it the energy associated with blowing of the wind? That's wind energy. But chemical energy is related to the chemical bonding, and that's why it's the structure, which is the structure of the chemical compound. That's why it's related to the bonds. Clear?
Doctor,
Yes.
B should be the temperature.
P, which P?
Choice number B.
B.
The random motion.
Exactly. Temperature is associated to the random motion. The temperature, not energy, but the temperature associated with random motion of atoms and molecules. Yes. Good. Okay, last question. When heat is absorbed by the system and work is done by the system, okay, the heat is absorbed. This means, is it going to be plus or minus?
Plus.
Plus.
And work is done.
It will be negative because it's done by the system on the surrounding.
Exactly. So which choices is right?
A.
That's it. This is the end of, okay, we still have 5 minutes, but let me stop here and I'll stop recording. And I'm going to, this is for chapters 10 and 6, sorry, 5. Chapter 10 and 5, okay? And from chapter 1 to 4, it's available in major 1. I'm going to discuss it in the next lecture. So I keep the recording for this one, and you can attend the next lecture if you want to attend the lecture about major 1, or you can listen to it in the YouTube, inshallah. All right. So before we leave, let's take attendance.
Doctor,
Yes.
do you have a channel on YouTube?
Yeah, of course. You do know about.
And how can I find it?
It's actually. Go to YouTube and then go to Dr. Rahman. Chemistry one. If you go this one, you'll go to the YouTube. You go and look on the YouTube and you'll find it. Okay. Okay, anyway. The attendance is open now. Let me